It's a material scientist's dream. Imagine there was a battery material that just wouldn't degrade at all. The material would somehow stay in the exact same state of health for hundreds or maybe even thousands of years. And every time the material would develop first cracks due to mechanical, thermal, or acoustical shocks, the material failure would just magically heal itself. Maybe like a forest or like a plant or human skin. Is that even possible, we ask ourselves, chemically speaking?
Battery Generation, brought to you by Celeste.
Welcome to Battery Generation, Professor Dr. Maitane Berecibar.
Thank you very much for having me in this podcast.
Let me introduce you to our audience really quickly. You are a professor for electrical engineering and power electronics at Vrije University of Brussels in Belgium. You are the head of Battery Innovation Center in the MOBI research group at your university. MOBI is an innovative research hub for electromobility, and your expertise, among others, includes emerging battery technologies, battery manufacturing, self-healing properties, and sensor integration. So let's talk about self-healing batteries. Would you first of all describe that term to our audience, please? What is a self-healing battery? What does that mean?
Yes, self-healing batteries is something that it's very novel in the battery scientific world. We are now researching it, and it's becoming more and more important topic. And actually, self-healing, what we try to understand, and as the name it says, is try to protect the batteries from degradation mechanisms that are occurring in the battery cell, and at the end, expand the lifetime by autocurative processes that we can have in the battery cell.
Let's dive in just a little bit here. So on the one hand, you mentioned prolonging the lifetime of the battery itself. And the second part would be some corrective mechanisms. So are we actually talking about a degradation that took place and that you are able to revert with your self-healing battery, much like maybe if I cut my finger and it self-heals? Is that comparable?
It is comparable, yes. So at the end, in self-healing batteries, what we have is that, for example, we'll have different materials, different compounds. One example that I like a lot is the usage of silicon. Now we are using silicon more and more in our batteries because of the properties that it gives. But silicon has an issue because when we are charging and discharging the batteries through the cycling process, the silicon expands. So that means that, of course, it can at the end break in different compounds, and we will have a capacity decrease on the battery. So we can use it for shorter cycles. So if we use a self-healing property, we can use, for example, self-healing coatings in which we will protect that silicon, and we will try to stop that breaking from the expansion of the silicon. And in this kind of concepts, silicon self-healing properties relies on.
Just to get that clear, once the silicon is broken, could the battery repair that silicon, or is it all about preventing it from breaking?
There are different concepts, and of course, some of them try to activate an action on the silicon that is broken. Other kind of actions will try to protect and keep the material inside.
So it's both.
It's both,
basically.
My first question actually is, silicon is already used in lithium-ion batteries. On the anode side, it's usually doping the graphite there. Is there self-healing batteries on the market already?
I would say not yet, at least from my perspective. However, we are now on it. And this means that the status in which we are now at market level is that we are developing the different materials, let's say, with the self-healing properties. And these ones are now tested on a prototype, tested on a battery cell that we can develop. And then from that, at the end, end, we will need to test. And what happens with the self-healing properties? That this comes with degradation and comes with time. So then we need to, at the end, test the battery for a period of time. And in that moment, we will be able to have the self-healing batteries sell in the market at European level.
If we take this concept to the end and say we achieve all that, do you have an estimate of how much additional lifetime you could actually achieve for a battery? Are we talking about a forever battery that just never dies, that I could just maybe send to space, to some remote space station equipped with some solar, and then they just have electricity forever?
That's for sure the aim, to have this battery that will last forever. However, what we are doing is developing our research understanding by different parts. Of course, at a certain point, everything comes together: self-healing, sensors, thermal management, and so on. So at the end, we are going to have, definitely, if we compare to the starting point of batteries in 1990 by Sony, with compare with that technology, the way that we have done already, it's huge. And I really would like to say that the way that we need to go ahead is also huge. So we will definitely have longer lifetime batteries in the future.
Can't you just name a number, just an estimation? How much are we talking about? Is that, I mean, all these efforts, are they leading to, let's say, a double lifetime, or are we talking maybe 5 to 3% more lifetime?
I don't think we will stay on the 2-3%. I would aim more for a double the lifetime. However, that's a little bit too much to say. But yeah, it would be. I think it will be quite big, the step that we are taking. But we should not understand self-healing as always coming back to an ideal or a scenario or a fresh battery with a beginning of life point. Of course, self-healing will try to recuperate or try to enhance the situation of the battery, but it's quite difficult that we will always stay in a freshly made battery state. So we will definitely go lower and lower with the different degradation mechanisms that can occur, and we will go to lower capacities and higher resistances.
Could you just summarize once more the reasons that, so to say, drive the research on self-healing batteries? What are the advantages you want to reach at some point?
This is a very interesting question. Indeed, in the battery world, we are now in a situation, in a transition, in which, because of this energy transition that we are facing, we need to have more batteries. This is an energy storage system that has very good characteristics, and we need to use them more and more. But of course, there is an issue with raw materials. So then we need to use the batteries that we have today or that we are going to manufacture in the coming years for longer time, so that we are more sustainable.
Are we actually talking about just changing, for example, lithium-ion batteries a little bit and then making them into a self-healing battery, or is this an entirely new set of chemistries or a completely new battery design that we're talking about? So is it something we can just put on the existing technology, or is it something that needs to be redone entirely?
Yes, one may think that this is a very novel topic. So you may think that maybe this is happening only in novel technologies. But when we think about how the self-healing properties or understanding comes from, this comes from degradation. This comes from the aging that is occurring in lithium-ion batteries. In this sense, many of the aging or degradation processes that can happen on a cell that is already already mature, that is already manufactured, that we can buy, can be exactly the same degradation that can happen, for example, in new coming technologies like solid state batteries. So the self-healing concept that we are developing can fit in many different technologies. We can talk about generation 3, generation 4, generation 5 even, and then we can, from those self-healing properties, understand which one would fit which technology.
As I understand it, there's lots of researchers focusing on self-healing batteries, such as mathematicians, people that do modeling, engineers, chemists. Is there actually biologists working on batteries such as organic materials? You could maybe imagine when now comparing self-healing to maybe human skin or a forest or something. Is there people from biology working in your research groups?
Actually, I would think that it's a little bit of a mixture of everything. Of course, the understanding or the first idea of self-healing comes a little bit from the human understanding or from nature understanding, as you are saying, a little bit more biological understanding. So that's a little bit the starting point. Why not applying this concept in batteries? But of course, afterwards needs to be a chemical process, needs to happen in the battery with the materials that we are using. And then at the end, of course, when you understand how can you apply that, you need to optimize that process and you want to apply that process. And then, of course, what we need to have is an engineering process. So I would say that at the end, it's a mix of the different kind of worlds that we have.
Let me come to that engineering process just a little more, because recently there have been a lot of headlines about sensors in batteries, maybe even in cells. So we were wondering, if I'm going to have a self-healing battery, I need to somehow know its state, right? I need to know whether it already degraded. So I would imagine there would be some sort of sensors required. Is that part of the concept for self-healing batteries? Can you maybe elaborate on that?
Yes, this is something that it's happening now, and it will start very soon on how to combine both worlds. We are understanding, in one hand, which kind of sensors can we use to understand the battery properties, and on the other hand, we are as well understanding which kind of self-healing properties can we really track or can we really interact on to have a better lifetime batteries. And what we need to have, of course, here, very important, is a trigger. Is a triggering that will, at the end, say, okay, the self-healing functionality needs to happen. And why? Activate, yes. And then, of course, when does this triggering need to happen? When do we need to say activate now? When we understand from the different sensors which is the status of the battery. So this is something that is now coming together.
You probably need to define some sort of threshold where you say, if maybe the voltage goes underneath a certain level of the cell, or maybe temperature, do you already maybe know which sort of sensors you need? Do you need to know the voltage? Do you know the resistance, or do you need the temperature maybe?
There is a menu of different sensors that we can use, and what it's happening now is the understanding of which sensors could be successful for the battery world. This is what we are now understanding. And there are many different kinds of sensors. There are acoustic sensors, electrical sensors, mechanical sensors, temperature sensors, electrochemical sensors. So, for example, if we can try to understand temperature sensors, this is something extremely important. Temperature is a threat sometimes for the battery. We need to control it very well. So if we understand precisely at the cell level where is the concentration of maximum temperature and how much is that temperature, we are understanding a lot of that characteristic of the battery. We can understand as well electrochemical sensors like impedance spectroscopy. Impedance spectroscopy can give us, in an overall, the resistance understanding of the battery, but also much more detailed understanding. But that already gives us a lot of information of the battery performance as well. And if we are talking about, for example, mechanical sensors, we can have stress sensors. We can link this to the previous topic that we were discussing on silicon. If we understand that stress factor of the battery itself, we can prevent, for example, gas formation in the battery that will lead maybe to a hazard. So that we need to link very well which sensor accompanies which kind of self-healing property.
Could you once more tell us why sensors in batteries and self-healing properties are always mentioned together? Aren't they actually two very different, separated research areas?
We can treat it as separate areas. We can have batteries only with sensors. We can have batteries only with self-healing properties. But now the next step on the research actions on batteries is to understand how can both be combined together, so that this will be a little bit the engineering that we were saying before, the engineering effect of both together. Because of course we need to understand that self-healing properties, maybe they need to get activated when they need to get activated and not before and not later. And this will be something that, for example, the sensors can really provide this information. And then in that sense, we will gain a lot if we can try to combine both of the worlds. However, independently, they can definitely work as well.
That's a great future outlook there. But let's take one step back, Professor Berecibar. If I buy an electric vehicle right now, is there any sensors already inside the battery packs?
Sensors is something that now in the battery scientific world is under research on different fields in different topics. We can have sensors at manufacturing level in the manufacturing line to produce better batteries. We can have sensors on the cells, as we are saying, inside the cell or on top of the cells, and we can have even sensors at the battery pack. Normally today, if you would have an electric vehicle, you would have sensors for sure at the battery pack. These sensors, they need to be there for understanding thermal management and thermal actions that needs to be done at the battery pack level. However, the sensors that we are developing now would be more into the cell level, inside the cell or on top of the cell. And this, of course, there is a big difference in understanding the different properties of each of the cells.
How can I picture that? How large are these sensors that are already put into a battery pack? And then the sensors that you might want to put into every single cell? Is that maybe comparable with the top of my pencil here, or how large are they?
Yes, it can be comparable to that, of course, depending on the sensor. It is space is critical. Space is critical for a battery pack, so the sensors needs to be as small as possible. So the sensors that are inside the cell, even more, because of course we need to cover them with different layers of the materials that we are using to develop the battery. But of course, on top of the cell, these are normally printed sensors that can be very, very flat, and they don't have nearly any space that they take.
And then you need to communicate that data between the cells, right? So you don't use cables, of course, but still, wouldn't that also just require a little bit of space, because you don't only have the poles to connect, but also the data links?
Of course, ideally this will come also. There are some research actions happening here. How can we connect and understand the signals of each of the sensors? So for that, at the end, what we are aiming at is to have cloud computing, is to have wireless connection where we can understand each of the data and what is happening there.
So So maybe in the near future, my battery will have a longer life if I have good Wi-Fi.
Well, I hope that it will not rely on your Wi-Fi, but it will be definitely connected. It really helps on having better understanding and faster responses on the different algorithms and management systems.
Let's say every single cell of a module is now equipped with a sensor, and you get the data, how much capacity, how much performance you get out of a cell. Wouldn't you need in the next step a very individual cooling and heating setup that, I don't know, might want to cool or heat up different cells? For example, when I accidentally supercharged my battery in a very cool environment, there might be some cells that degraded much faster than the other ones and might want to be treated very differently from the cooling and heating system. Is that possible in the future?
It's possible. Definitely, it can be even enhanced with the usage of different sensors per cell. But I can say that there are many activities already ongoing today for the better development of the battery thermal management systems. In this case, we are having different kind of thermal management systems and cooling systems that up to now it has been a little bit either air-based or either liquid-based with maybe a refrigerant that we can use, but we are more and more using hybridization of both, and even phase change materials that we can use for the cooling systems. But on top of that, there are other activities that are ongoing today that we can apply today, like for example, smart charging. As you are mentioning, of course, when it's very cold, we need to maybe have a heating process in the battery so that this charging process can be faster and can be with a less aggressive to the batteries. And in the same way, for example, when we are going to fast charge produces creates a higher temperature, creates warmth in the battery. So how to do this in the best way, depending on the battery characteristics of it. And what is happening a lot as well is, because this is a lot of data, this is a lot of understanding, algorithm development, this at the end creates a lot of usage of the computational effort of the microcontrollers. So then at the end, we need to have as well other kind of solutions like hardware in the loop, cloud-based technology, that we can have more accurate and quicker understanding on how to charge our battery, for example, in different temperatures.
Let's now talk about battery safety as well. I know from a Chinese electric vehicle manufacturer that actually monitors all of its batteries via the data you just mentioned, and they are actually able to see the state of health of all their batteries, including if someone has a problem with her or his battery. So it's probably also a topic for battery safety, right? I mean, if you monitor all these data, maybe a smart battery can lead to less accidents, right?
Yes, totally. We are talking about the longer lifetime. However, of course, sensors, self-healing and thermal management, this is indeed highly linked with safety. So per definition, we will have safer batteries. However, the batteries that we have now in place are, of course, very well equipped and safe already, but we will have even safer understanding batteries.
If I actually have a really self-healing battery, just imagining the concept comes to pass and is there, I would probably not even need to worry about the battery malfunctioning so much, because if it does, it either shuts down way before if it can't handle the self-repair, or it will self-repair and I don't ever get to that point where I actually have a critical malfunction.
So yes, of course, this is something that is now changing. The state of health normally relies a little bit on the capacity decrease of the battery, but now when we are talking about self-healing, when we are talking about sensor implementation, we are of course understanding the capacity decrease, but we are also understanding the resistance. We are understanding the specific degradation mechanisms that are happening. and we are understanding if there is pulverization, if there is microcracking, if the solid electrolyte is increasing, how much. So then in that sense, the battery management system can go now to novel concepts in which it will rely on other aspects as well, and it can in that sense have a better and more accurate understanding of the battery phenomena.
Let's now skip to the topic of manufacturing these self-healing batteries, smart batteries. I'm pretty sure that it's very, very costly to implement all these sensors inside a battery. How would you convince a manufacturer of producing these self-healing batteries? And a serious question now, do you think a manufacturer even wants to sell them if they existed, since self-healing batteries would probably be the last battery they ever sell, right? Since it's self-healing and I don't have any incentive to buy the next one.
Well, of course, it's tricky. It's already tricky to manufacture the batteries that we have in place, to have them very, very equal to each other with a very accurate process. So including sensors and including self-healing functionalities and materials, that creates a new challenge on the manufacturing. But we are very well prepared, I would say, at European level. Battery manufacturers at Europe, they are very well involved in European projects that are ongoing with these self-healing and sensor activities. So they are already understanding how to do this. But of course, we need to wait to understand which are the sensors that are going to be applied and where to locate them and how many to locate them, and the same with the self-healing. But if I would put myself on, if I would be a battery manufacturer, I would say that why not to have the best quality and longer lifetime batteries? Because at the end, we are now facing a technology that will be further improved, and we will go to novel technologies, and we will go to more sustainable technologies. So we will need to go into this race. So I don't see a problem with having long-lasting batteries if I would be a battery manufacturer, of course.
You mentioned before that you have so much data that maybe you will process over via cloud computing. Just a quick question: do you see AI or machine learning as having a part of that self-healing battery to kind of analyze it, or is that something you can actually already engineer with the equations we have, with the knowledge we have?
This is, I would say, well established. When we are talking about the self-healing sensors, thermal management as well, we are using, I would say, today everything based on machine learning. We are developing on a European project, Spartacus, state of X estimation algorithms for the performance and understanding of the sensors that are implemented in the cell. And this definitely it's applied already, because we already have a huge background and a huge understanding on how to do this already with not sensorized cells or non-self-healing batteries. So this is something that we directly can apply. Definitely we need to have basic understanding and proof of concept, but from that moment on, we apply directly smart tools to develop the next coming technology with the machine learning and artificial intelligence as tools.
Another topic I'd be really interested in would be a second life of batteries. You talked about collecting all these data from the cells, the single cells, but the modules and packs as well. Isn't that something someone in the future could be interested in when buying these used batteries?
Yes, I think it really makes a difference. If we understand that, for example, a battery is already used in a passenger car and needs to move to a second life scenario, if we understand that the batteries have self-healing functionalities, has sensors to understand better what's the current performance and the status of that battery, I think it will be a big difference. And it definitely can enable a usage for longer lifetime, more cycles in a second life scenario with a safer battery as well.
In my mind, I was just comparing it to the kilometer counter in the car, which is maybe just a very crude number to estimate how worn down a car is. But if with all that sensor data, I would actually be able to, when selling a battery for second life, to label it very precisely on what maybe lifetime to expect from it and what kind of usage it would be suited for, because I have all that.
The digital battery passport is something that is now ongoing, and in that same way will as well be an enabler for second life, because we will understand what is the history of that battery, what's the actual state of that battery. But of course here what is really key is the understanding of remaining useful life algorithms and state of health algorithms. This really provides the real understanding of if we can use that battery, or where can we use it as well, in which kind of applications. On grid applications, some applications are they need more, let's say, higher requirements than others, and that is key to understand how to match them well. And with the sensors and self-healing will be even more feasible.
Last question for this podcast. What do you think is the outlook and the goal of your research when you look at the next, let's say, 3 to 5 to 10 years? Will we see these self-healing batteries on the market? And if yes, what applications is the first one to target?
I totally believe that we will have these self-healing and sensor-sized cells, although we will need to wait a little bit to see it on an application. What we are trying to prove is the proof of concept, is the self-healing concept, is the sensor concept, how to apply this in the technology that we have now in place, and it will come in the future. And of course, one of the targets, it's transport. It's passenger cars, it's buses, it's trains, it's everything that we need to electrify more and more on transport.
Thank you so much for this talk, Professor Berecibar. Thank you for your time and your expertise. Dear listeners, now it's your time. Please comment in the comment section or send us an email. That's hello@batterygeneration.com. See you next time. Thank you so much. Bye-bye.